thanks for coming. I know it's after lunch. It's very hard. So my talk is about continuous delivery in product development teams, or you can just rephrase it as continuous delivery for the rest of us. A little bit of context and about me. I'm Amir, head of engineering for TradeMe Jobs. There are lots of other people from TradeMe family here. I'm presenting on behalf of them. I used to be a software developer. I still try to code as many times as I can. It's very hard. And I learned about lean product management and all those things from my previous job that was like in a car manufacturing companies and pharmaceutical companies. And it's interesting to see that all those concepts slowly come into IT. A little about our company. Well, we have a TradeMe as kind of like a family of different verticals, and jobs is one of them. We are one of the largest job boards in New Zealand, and we are very much focusing on job hunters in the blue collar sector and job advertisers. And we are one of the commercial businesses within TradeMe. So this is important to know why we are doing it, because we have a central team that's like an operational team, and we have lots of different verticals that are mainly commercial. 4 years ago when I joined, I was the only developer. Now we are about 30 developer, tester, QA, product, design. So we have the whole team. Another thing is about the difference between product delivery team and technology and engineering team. The terminology is a little weird here. So we are kind of a dark matter of industry, because we exist and we are like a big portion of the industry, but normally people, when they talk about software engineering, they are talking only about the cool things. But we are paying the bills. We have a relatively concrete product roadmap. We exactly know in the next 1 year or 3 years what we're gonna do and what we're gonna build in a very high level kind of thing. We are driven by commercial results such as revenue, engagement, audience, and NPS, that is Net Promoter Score, if you're not familiar with that. We focus on product problems rather than in engineering problems, so we very much try to find a way to solve a problem for our customers. We are very much end customer focused. And when we joined, most of us, they came from like a very much engineering background, and then we joined kind of a product development team. We noticed that there are lots of people over there that are from a sales background, accounting background, marketing background, and we noticed that we need to learn their language and kind of talk in a way that they understand us. If you are in this room, probably you are using some sort of like a lean product management. If you don't, there are lots of good material out there. We are using dual track product development. That is, at the same time that we are working on the discovery, we work on the development side of that as well. The way that it's working is our designers and product managers, they just get together and try to ideate using design thinking or any other kind of a lean product management technique to find what problem they want to solve. They kind of do lots of prototyping, and then when they are done, they just come back to us and say, hey, put this one in production. And then we try to put it into production. We start developing this thing called MVE, or minimum viable experiment. And then we put it into production. We measure if it's working fine. Industry standard is about 80% of the time it's not working fine. 20% of the time it's working fine, and then we pass it to the discovery again. We develop on top of that until the product is perfect or close to perfect. Cool. So that was the context. The problem is those red lines. We have a discovery phase, delivery phase, and operation phase. Whenever we are talking about DevOps and continuous delivery, we very much focus on the relationship between engineering and infra. We kind of forget on this the other side as well. This is something that Jez Humble calls water scrum fault. So the product team and our designers, they just go to the room and they work for 1 month, 2 months, and then all of a sudden they come back to us and say, hey, this is an idea, put it into production in the next 1 month. And then the engineering team are just like, how to do this, deadlines, we are not good with deadlines. They do their own agile kind of flavor. They do their stand-up. They are happy that they are very much agile, but they are not actually. And then after that, they just pass it to the infra and said that this is our Kubernetes cluster, put it into production, and infra said this is the first time we are doing this. There's a compliance issue, there's a security issue, we can put it into production. So as a hint, what we noticed that we need to remove that line between product and engineering. This is a lesson that we learned, that we make sure that engineering team is part of the ideation session and discovery phase from day one. And then we saved a lot of time by just being engaged with them from day one. What we noticed is sometimes engineering teams say, hey, you want to build this thing, if you do it this way, we probably can save 2 months' time. And most of the times they are happy with that. I'm saying, oh, that's cool, let's do it. Or they can plan ahead before the actual product gets to the engineering side. They actually can plan ahead and build some infrastructure for that. And the other thing we did was we kind of removed that silo, and now we have kind of a dotted line. In the product delivery team that we are, what we did was we have a person in the infrastructure team that we have a weekly catch-up with them, and then we say that, hey, these are the 10 things we need from you. Which one of them you can do for us? And then we kind of compromise. We changed the architecture, we prioritize, and then we said, okay, these are the 3 things that we can do for you. These are the 4 things that you can do, and then we can review it and push it in production, and then the rest of them, let's just push back. And then we make sure that that relationship, I work on this animation a lot. We make sure, it was kind of a trial and error for us to find out where we should draw that line, to make sure that we still have time to focus on the product rather than engineering, or it's not too much. It's kind of finding a right balance in, we just try to make sure that that's kind of like not a waterfall flow. We get some feedback from them as well. If we don't do that, so the thing is, when we started learning lean product management, there was this mantra from NASA that said failure is not an option. And then very like in an inspirational way, they told us that, oh, actually failure is an option. If you can fail fast and often, definitely do that because you can learn from it. But the thing is, if you can't fail fast and often, then failure is the only option. What happens is sometimes experiments take longer than building the actual product. You spend 6 months doing an experiment to find out if the actual product is working or not. But you need to remember that 6 months is probably a lifespan of a startup that is probably working in a garage across the street. We fail to measure and learn from our experiments. We end up with a very mediocre product, and then we fall from our competition. There are numerous instances of this in the industry. What we did was we tried different recipes from the industry. We noticed that there are lots of companies, they have different opinions about how to build continuous delivery in their teams. And then we kind of adopt and localize them. So I'm going to mention some of those ideas here, but again, you can mix and match based on your requirements. The first thing is you need to make sure that you have a senior management buy-in. So we wanted to spend about 10% or 20% of our product delivery team to work on continuous delivery and build those capabilities within our team. You need to make sure that senior management team understand the importance of continuous delivery capabilities and the benefit that it brings back to the team. And then we have this thing called product roadmap that shows us that, okay, for the next 1 year from this time to this time, you are going to work on this specific feature. We make sure that we have a dedicated swim lane in our product roadmap. If you want to know how we did that, we just show them this chart. And we said that this is a peer-reviewed study by, well, I think it's kind of like a lean enterprise book, and then after that, the Accelerate book. This is a peer-reviewed study. If you invest in continuous delivery based on the evidence that we have over 4 years, you get improvement in your IT performance. And as part of that, you gain organizational performance as well. That worked for us because they noticed that if they get IT performance, they can release things faster. So 10% was really justifiable. And this is our swim lane. So the others that I blew, this is the actual product roadmap that we have, that those are all feature developments. We are allowed to spend 10 to 20% of our whole delivery team working on continuous delivery initiatives. We reset our metrics as well. So we had so many weird metrics. And we decided to just settle on 4 metrics that matter. The first 2, cycle time, lead time, and frequency of releases, shows that how fast we can get to production, and the other 2 shows us the quality of that. We used to be a company that we were very much focused on mean time between failures. We were really proud of that, and then we noticed that it's actually meaningless. So at the moment, we are trying to build capability to focus on mean time to recover as well. The last one is the least important one for me, but it's a kind of an indication that something is wrong. If frequency of release is going higher than normal, and the number of bugs going high as well, I know that there's something wrong and we are not ready for that frequency of release. We either need to work on our build pipeline, unit test, change the process, or anything that we can do to stabilize the number of bugs. I have 2 favorite unofficial ones. The one metric that matters to us is team happiness. We used to measure that using a normal survey that we were publishing to our team every 1 month. And you could see that as soon as there are tight deadlines, or there is a production problem, or there is impediment, you could see that it's slowly going down. That's my favorite one, but it's very hard to measure. So you may not want to use that as your main one. And then the other one is the junior developers' stress during the release. So we have this thing that we have this saying that we say that human being tends to get used to misery. So if you ask a senior developer that is working on using the same build pipeline or release process for the last 5 or 10 years, they're quite happy with that because they hate change. Sometimes we approach a junior developer who is very new to the team and said, hey, you're 2 months here. How did you feel about your last release? Did you feel any stress? And most of the time the answer is yes. And we know that, okay, now we need to focus on process change to fix some stuff. And that means maybe unit test, make sure that we can roll back faster, reduce the stress, or just tell them that, hey, it's fine if you break it to production, it's fine. There's this thing as well, that code is added by me. Fish code and visitors stink after 3 days. So this is our kind of a way to get to trunk-based development. There's no evidence that Franklin actually said that. So what we did was we said, okay, this is we got the chance to work on continuous delivery capabilities within a product delivery team, which is awesome. How should we approach it? We set a very clear, dreamy vision for the future. We said that imagine that in 3 years, you can do this, this, this. And then based on that, we built a roadmap, and we started changing our culture slowly to get to that kind of a dreamy future within 2 or 3 years. Some examples was for developers, we set the goal that I said, hey, imagine that considering that we believe that trunk-based development is a good thing, let's get to a point that you willingly release per day and don't use feature branches more than a day. For our testers, we said that what it takes that when all the steps in our build pipeline is green, you're happy just push the button and release it to production without actually manually checking things for 1 or 2 days. And then for operation team, it's just a metric that we have the time to first hello world, that we need a cluster in production. Now it takes 6 months. How can we get it to 1 month? And then this is another recipe that we did. We used to don't touch our build pipeline. And because automation is one of the main things that we want to focus on as a continuous delivery capability, we started taking ownership of some parts of our build pipeline, not all of it, but some parts of it that make sense for us. And then we started refining it based on our use cases. The goal is at the end of the day, when, first of all, we get a very kind of, this is from a continuousdelivery.com. The idea is, first of all, we get very fast feedback if there is a problem. And then at the end of that, it's robust enough that when everything is green, we are confident to just push it to production. The other thing that is our main focus is making sure that this process takes less than 10 minutes or less than 5 minutes, because if your build pipeline takes about half an hour or 1 hour, then developers and testers, they inherently decide to keep 5 or 6 or 10 days of worth of work rather than spending 2 hours per day to release the code to production. So we just need to make sure that the time to green is very low as well. When you are coming from a company that is around for 10 or 20 years, there are lots of problem with trust between different teams, because in the last 20 years, there was always this thing that developers, they don't trust testers, they don't trust operation don't trust anyone. So one of the ways that we decided to solve this kind of a trust problem is fitness functions. The way that it's working is you have a compliance problem, you have observability obligations, you have security analysis that you need to run on every release. The way that you can solve that is from a team that really wants that kind of a compliance to be applied to every code that is getting into production, define those fitness functions as a template and make sure that every team running those fitness functions at the end of the build pipeline in an automated way. So technically, you are removing all those problems around. This is technically the answer that this doesn't work in our company. You can use fitness functions to remove most of those audit problems and compliance problems. The other thing is changing architecture. Another recipe is changing your architecture. In engineering, this is controversial, I know, but in a product development team, our main focus is to make sure that we change an engineering problem to a non-engineering problem. One of the ways is probably just change the tooling you are using. It is 2019. If a tool does not support version controlling as a kind of a configuration, it cannot be automated, just don't use it. There are lots of other tools that you can choose to apply in your process, and probably they are better as well. The other thing is high engineering cost. I'm going to make a Kubernetes joke here. I'm not going to use Kubernetes in a product development team without 5 or 6 levels of abstraction, because that means that I need to spend 40% of my product development capacity on maintaining a Kubernetes cluster. And then the security aspect of that as well, and all those things. We are very much a monolith company, but we are applying some of the microservices practices as well. We are using circuit breakers, bulkheads, and feature toggles to maintain our mean time to recover. We are avoiding code sharing as much as we can. The thing is, this is kind of, again, controversial, but we noticed that every time our cycle time in the last 1 year went up, it was mainly because of code sharing. You need to justify exactly why you are injecting a dependency into your code base. Sometimes it makes sense, you can justify it if it's a very specialized piece of code. Sometimes, like left path, just don't do that, just write it yourself. And then macro front-end architecture is really useful as well in order to maintain your cycle time and release frequency. Evolutionary architecture as well. I got the fitness function idea from evolutionary architecture. The other thing is process change. Again, in a company that is around for 20 years, there are lots of rules that everyone just follow, but they don't know why they are following it. And then when you ask them that, why are you doing this? I'm sad because we used to do that. And no one knows actually why. And things change very fast now, so lots of those rules, they don't apply. For example, we had this rule that every piece of code that gets to production needs to be specifically, the test execution in a manual way should be done by a tester. Then we change it and say, well, another developer can do that as well if the risk is low. And nowadays, most of the code that we are doing, the manual testing is actually done by developers as well. It helps us, and then the same thing happened with the release as well. So we said that you put it into production, you maintain it, you make sure that you monitor it as well. We noticed that this actually helped us from reducing our cycle time. The number of bugs went down as well, because we noticed that when developers are responsible of manual testing their own code, they're actually writing it in a more testable way. And then our testers managed to spend more time on automation, which was very useful for us. I'm not going to talk about SLO, because I think we covered it today, but it's really useful for us. So we adopted the whole idea of error budget for some of our services, and that was really helpful for us to reduce the friction between product and delivery. We introduced that recently for a couple of our products and said that release as many times as you want, but make sure that you are within your error budget. We actually had an incident 3 weeks ago, and then the whole delivery team had to drop tools and focus on fixing bugs for 10 days to make sure that they get to a stabilized situation. One thing that is very interesting is when we were missing error budget, we noticed that our net promoter score went down as well. So that's another thing that we normally don't talk about, but our customers were not happy as well, because the system was like flaky and it was not as good as before. We have some suggestions from an SLO perspective for a product that is like written years ago. First of all, talk to your product manager. It needs to be like kind of like work together to come up with that service level objectives. We noticed that for some of those products that we have a very high objective, there are actually only 9 to 5 applications, so no one using them after 5 o'clock. Trial with just with one service to see what's the process. The first time that we started having a chat with our product manager and said, hey, this is this thing about error budget. What do you think about it? They went and they thought about it for 2 weeks to see what their customer actually want. So we keep it simple to avoid exceptions. We are using the number of 9s as well. We have alerts for any of those. When they break, we automatically get alerts so that we don't have to reactively check on them. For the existing services, we define the SLOs, current situation, the situation that we want to be, and then we came up with plans to get there eventually. For example, if the uptime is 97% and we want to get to 99%, we came up with different actions, for example, changing the architecture or make it more redundant to get to that. Product development team, we didn't have on-call engineers. We were relying on our central team that they were doing a very great job. But then for some of those microservices that we had, it was hard for them to manage it for us. What we did was we just implemented a very, very simple way as an experiment to see how it's going to work for us. So we just have a Google Calendar that you put every day so that this person is responsible for on-call, triage, all the alerts, and monitoring production for the whole day. It's a good experiment. We just did that we started doing it for the last few months, and it's actually working for us. The good thing about that is you do it one day per month, and you know that for the rest of the month, no one come to you and ask you questions. So it reduced the you can just focus on your work. And at the same time, it's kind of a very good way to share your knowledge. I used to be the only person who knew about this specific service. Now everyone knows about it. And don't expect people to work for free. That's important. Alerts and dashboards. We didn't have a specific alerts for our services. Then we moved to the microservices architecture and we said that the alerts we have from a central team doesn't work for us anymore. We are lucky that we have expensive licenses from Splunk and New Relic. So we started using it. That's it. One thing that we noticed is we are not using emails. In our previous jobs, we always remember this mailbox that is 30 gigabytes. Unread emails and no one can read them, and your observability is as good as your search on Gmail or Outlook. We make sure that they are actionable, they are simple and no exceptions. And then we ruthlessly audit them every now and then and remove lots of alerts that we have. Some of those that are not really a good idea, or things change, or the service, kind of the architecture of the services change, so we kind of remove them. If you see at the end of, for example, that's kind of like a mock alert that we have. There is a link at the bottom of every alert that we have that is a PCR. It means that it doesn't matter if you know about that service or not. As soon as you get that, by clicking on that, you can go to the problem cause resolution recipes. Very cheap to implement, very good, very easy way to maintain your knowledge about a specific service. So those PCR, this PCR is coming from when I used to work for a customer help desk kind of software. So they have this thing that a person calls you and says that I have a problem. Is this your problem? These are the causes. These are the potential resolutions. So we are like maintaining these PCR runbooks, and as soon as you get an alert, you can just go and say that, okay, these are the 5 or 6 things that I need to check. One problem with PCR runbooks is that sometimes it creates bias. The problem is right in front of you, but you go to all the 5, 6 items in the PCR, and then you come back to the actual problem. So it's kind of something that we need to be careful about. Post-mortem and incident management. We are lucky enough to work in a company that is blameless. We don't judge each other when we break production. It happens to the best of us. The whole idea is we put some processes in place, and we are changing them every 1 month as well based on what we learn. We have a process, very clear flow chart that, okay, this is an incident, this is a priority, this needs to be done. We even have like something that, hey, this impacted these many users. You need to apologize. We have a comms team that they take care of that as well, which is very nice. The person who leads an incident and responsible for communication and all those things, they are not responsible to doing the actual fix. So it's kind of reduce the friction as well. And the person who's fixing the stuff, the problem, incident, they can actually focus on incident rather than taking care of all the communication. After the issue is fixed, we meet in person and we discuss it. Sometimes if the issue repeats after a while or the incident is like a really bad incident, we have a retrospective for that. And then based on that, we get feedback and we change our process. Do we need more unit tests? Do we need UI tests? Do we need to change the process? What happened? And then we write up with action points after the post-mortem as well. We have this cool tool called Bergerac. So when the incident happens in a production room, the person who is like leading the incident, they can create an incident, and that is automatically just connected to all of our tooling as well. This is another very cheap way to manage your incidents. The cool thing about that is, at the end of that, when you are closing an incident, it gives you the first occurrence and incident result time. Based on that, you can calculate your mean time to recover. So mean time to recover is one of the hardest things to calculate, but this actually will help us with that. So in summary, so these were all the recipes that I had in mind to discuss and share with you. When we started this kind of a journey in the last 1 year, we were thinking of it's all about tooling, and then we noticed that no, it's more about people and culture. I think we know that already. And then it's about changing the process, and then based on that, it's about technology. So the approach we took is, if you want to implement a cool thing that other companies they do, we do the same way that we develop products. We do the minimum viable experiment. I'm saying, oh, it's actually working for us. Let's build tooling around it, or it didn't work for us. Let's not do that. We have a clear vision that where we want to be in next 3 to 5 years. The other thing is when you talk about automation and automating your job away and all those things, some people, they may get a little anxious about what about my job in the future. You need to make sure that as a leader of your team, you assure them that it's not about like we make you redundant. It's about that free up your time so that you have a better work-life balance, focus on automation and focus on building cool things rather than clicking on the buttons. Make sure that you have a senior management buy-in. That's the most important reason. That's the second most important reason that IT projects fail. So make sure that your management and product team buy into having continuous delivery capability because they have obligations as well to deliver things. And then the other thing is you read lots of these white papers that themselves, this company is doing it this way. This company is doing continuous delivery or releasing things in this manner into production. Because it works for them, it doesn't necessarily work for you. It works for you. You need to make sure that you adopt them, extend them, and localize it based on the culture of your company. Otherwise, you probably implement something that is not a problem in your company anyway. I think that's it. Thank you.